Okay, here is further discussion on chords, something to think about. Now, I'll call this a second proof that a triangle inscribed in a semicircle is a right triangle, but actually it's not so much a second proof as sort of a reinforcement that this is a special case. It's because we used this property to prove that the uh, the result that we're showing that it's a special case um, for. And that is if you consider a diameter that goes through a circle, this diameter right in here. And you can think of the diameter as the chord, as a chord that goes, but it goes through the center of the circle. And you know that the angular extent of that chord here is 180 degrees, right? 180 degrees because it's a semicircle. And that if we draw then the inscribed angle for this included center angle right in here for the chord, we know that the inscribed angle is 1/2 of the center angle here, 180 degrees, which tells us that this angle is 90 degrees. So this, you don't necessarily need to remember this as anything but a special case of the broader principle that we have been talking about. Let's now look at some potential properties that can be deduced uh, from uh, from what we have been discussing here about chords and inscribed angles. Let's draw this angle right in here that goes, let's draw this line that goes from here up through the center of the triangle like that. Now suppose I ask you, what is this angle right in here? Can you tell me what this angle is by any chance? Right there, that angle. Let's call that angle X. Okay, so this is angle X. Well, what do we have? We know that the distance from here, from this point to this point, is equal to the radius of a circle. We know that the distance from this point to this point is equal to the radius of a circle. And the distance from this point to this point is equal to the radius of a circle. Okay, if that's the radius of a circle, then this angle right in here is equal to this angle. And this angle right in here is equal to this angle minus 180 degrees. So we do this angle, subtract that from 180 degrees, that gives us this. But this angle minus 180 degrees is equal to the sum of these two angles. So this angle right in here is the sum of A plus C. But because this is an isosceles triangle, A and C are the same, so this is equal to 2A. And that tells me that this angle right in here, angle X, our unknown angle that we're trying to find, angle X, is equal to 2A. Okay? I hope you can see that, hope you understand that, and it's not overly complicated. Till next time.